Hello, everyone. Good day, and we're going to go ahead and get started on our webinar today. Thank you for joining. It's a pleasure to welcome you to our webinar hosted by the Citrix Ready team. And this webinar will be provided by SolidFire, one of our key Citrix Ready partners. My name is Greg Fox, and I'm the director of the Citrix Ready Partner Program at Citrix. And this will be an hour-long webinar, and we'll be covering a variety of topics today. We are recording the webinar. We'll make the slides and the webinar recording available. We want to allow about 10 to 15 minutes at the end of the presentation to allow you to ask questions, so that anytime throughout the webinar you can post your questions in the conversation portion of the GoToWebinar environment, and we'll make sure that we queue those questions up and answer them in the order that we receive them. So we encourage you to be thinking about the questions that you want to answer. And if there's any questions that we aren't answered during the webinar, you can send a note to citrixready@citrix.com, and we'll promptly reply to your question. With that introduction, let me hand it over to Keith Norby to introduce the topic and our speaker today.
Thank you. Good afternoon. My name is Keith Norby. I'm the Senior Business Development Manager at SolidFire, and we've got a webinar constructed for your benefit today around the title of Don't Believe the Hype, You Don't Need Dedicated Storage for VDI. This title was inspired not only by the joint solutioneering between Citrix and SolidFire, but also for the broader topic of people dedicating storage for VDI. And then a little later in the presentation, some goodness around cloud platform and how you put that into a desktop as a service model and how that plays forward. With us this morning is a very special guest and presenter, Aaron Patton. We'll let him introduce himself, but he's on the Tech Solutions Group with myself and several others at SolidFire. He does a lot of dedicated work towards VDI and virtualization on multiple disciplines, and we'll get into a lot of the depth of the content that he intends to address around both platforms as we address VDI. But before we do, let's hear a little bit about the Citrix Ready program in case those of you that haven't ever gone through that or know what the context of a Citrix Ready program is. Why don't we hear a few bits of information about that?
Excellent. Thanks, Keith. This webinar is brought to you by Citrix Ready. Citrix Ready is our technology end-to-end partner program that's focused on interoperability and compatibility of key products and solutions focused on our Citrix portfolio. And we award Citrix Ready to third-party products that have successfully met rigorous verification criteria set by Citrix. And it gives customers added confidence in the compatibility of their joint offering. It's been around since 2007. We have over 950 technology partners that are part of the program with over 27,000 product verifications to date. And as these products are verified, they're listed in the Exchange Marketplace catalog, where our resellers and our customers and Citrix Field can find these trusted solutions to work in their environment. We have about over 2 million online catalog views of the Exchange Marketplace history to date. So it's a great program. We're pleased that SolidFire is a key part, a key Citrix Ready partner. Next slide. And I would say that Citrix Ready is the #1 source to evaluate verified partner products for customers making a Citrix purchasing decision. So it's a great program, great success, and we're very pleased to have SolidFire, a key Citrix Ready partner, presenting today. So with that quick introduction, let me hand it back to Aaron Patton, who will deliver the webinar.
Good afternoon, good morning to all of you all that are on the phone. Pleasure to be speaking with you today. My name is Aaron Patton. As Keith mentioned earlier, I'm a VDI virtualization architect for the Tech Solutions Marketing Group inside of SolidFire. To give you an idea of where I come from, prior to coming to SolidFire, I was actually the platform architect for the specialized business systems at VTE. So I designed and built vBlocks specifically for VDI workloads. The high-performance database vBlock was also my baby. Before that, I was a solutions engineer over at EMC, where I did a ton of work on View before it was View in the VDM days with the vSpecialist group. Wrote a lot of white papers for EMC in that space. Had a really good time doing VDI architectures in that context, and I'm happy to be doing that again with SolidFire. So, with that out of the way, what we want to talk about today is why do we dedicate storage for applications, right? So, inside of a data center, there are islands of storage everywhere that are dedicated to the applications living on top of them. And on the surface, this makes pretty good sense, right? You know, we design application stacks that are of sufficient size with a certain set of requirements in mind, and then we implement those requirements in a new system, right? And the reason that we do that is based on a lot of problems that we have, right? And specifically to the VDI context, we dedicate storage for VDI because it's difficult in discovering how to integrate that workload into an existing infrastructure, right? So we've got this thing called VDI that we're going to do, and we've heard a lot about it. You know, we've been told that we need to do it. We're not really sure about what it is or how it behaves, and so in many cases, whenever we're getting ready to stand up a pilot or POC, we'll dedicate equipment to that and say, okay, this is my VDI POC. It is this thing over here in the corner. All right, one of the other reasons that we dedicate storage is the unpredictability and volatile nature of that VDI workload. We've got very big swings that go from these boot storm, which are, you know, very sequential, large read application workloads, up into these things of application patching and updates, which happen to be, you know, very write-heavy, small random workloads. And designing infrastructure that can handle both of those things simultaneously is difficult, to say the least, right? We also dedicate storage because we don't have an ability to guarantee an acceptable user experience when we're fusing VDI into an existing infrastructure, right? The way that we might, you know, carve off a RAID group or an aggregate or some other LUN on our storage to do VDI, we're not really sure about the interplay between those two applications and how the workloads from one will affect the other. We also have this difficulty in scaling storage assets, right? So if we're going to carve off a little bit of our infrastructure, if we decided that, you know, we're going to do a POC that's maybe a couple hundred desktops, right? You know, we'll get through our POC, we'll shake it out, we'll say, okay, here's what we want to do. But then, okay, well, we did a POC with 200, but we actually need 2,000 desktops, right? And growing from 200 to 2,000, in many cases, is a very difficult proposition if you're trying to shoehorn that into an existing storage array. So again, you know, we kind of set that off, right? An additional issue here is that scale-up storage models don't enable elastic scaling of VDI workloads. And we'll talk about this more in particular in the middle of the presentation. This is actually a pretty important concept, so I want to spend some more time on it later. And the other thing is that this idea of complex desktop and management schedules with VDI. So in the VDI context, in many cases, we have got users from a lot of different time zones, maybe even different continents, who are connecting to this infrastructure. They're doing whatever it is they do. They're doing development work. They're running a call center, whatever it may be. And then scheduling the type of desktop-centric management tasks that have to go on in a VDI context, along with other workloads like databases or ERP programs or things of that nature, becomes extremely difficult because now we have to tie our maintenance window to many different lines of businesses, right? And so that becomes very hard, right? So how do we do that? And so for all of these reasons and more, we tend to dedicate storage to VDI. And in an enterprise environment, that's hard enough, right? But when you talk about multi-tenant, when we talk about the cloud, this becomes almost impossible, right? If we're actually sharing infrastructure between multiple different tenants with different application structures, scheduling things becomes an enormous issue, an enormous burden for the operations group as they try to figure out, okay, well, how do I do what I need to do with moving to a new gold image on my VDI desktop at the same time where I've got my end-of-year processing happening on this big accounts payable database, and I can't interrupt that, so I really can't reboot this or that. And so all of these things become much more complicated in a shared storage infrastructure, right? So we're sharing storage across hosts, right, because we have to have that in order to run these clustered systems. If we're running on top of VMware or Xen or anything else, we have to have shared storage in order to run these things. But we're not really sharing storage across silos, right? And that's kind of where the genesis for SolidFire comes in. And one of the problems that you have when you run these aggregate workloads together is this idea of noisy neighbors, right? And in our case, we're going to talk a little bit about VDI, so we'll talk about noisy desktop neighbors, right? So if you've got a large population of desktops, you've got users doing all sorts of things. They're not coordinated events, right? So you've got large events like logons and patches and all these things that are somewhat coordinated. But during the course of the day, again, you've got users over many time zones, over many geographies who are logging in. You've got this very complex workflow of I/O. And if you're running this on a traditional array that doesn't have the ability to do any type of QoS, you'll have applications that start up some type of workload that demands a lot of I/O from the system or a lot of performance. And in those cases, the system only has so many I/Os to give, and so if you're requesting more than it's capable of giving, it's going to steal them from somewhere else, right? And so we see that as this noisy neighbor problem where high I/O events cause problems for everyone else on the system. Now, the QoS policies that SolidFire is able to implement can take this kind of chaos and turn it into order, right? So in this particular graph, we see, in this case, it was a SQL query that was kicked off that demanded a whole lot of resources from a couple of LUNs and kind of impacted the performance of some of the VDI desktops. But then we went in and applied a QoS to everything and said, okay, for these specific applications, we're going to guarantee this level of performance. And we can see at the end that those actually panned out very well for those applications. And what that allows us to do is to give an SLA that we can enforce across those different workloads, which is critical when we're talking about multi-tenant workloads in the cloud environment. And when we start really talking about other applications, it gets a lot more complex. What does your application profile look like when you mix SQL with XenDesktop on VMware with a cloud platform infrastructure, and then you've also got things like ERP or other type of warehousing applications or your applications that are specific to your line of business? The interplay between all of those applications is very complex to deal with. And so we're kind of here to say SolidFire is shared storage for all, right? We want to introduce a scalable approach to VDI storage in the enterprise where we can say, okay, it's all right for you to mix these applications because we're going to show you how we can guarantee performance for these specific applications that we're running on the shared storage infrastructure. And so when we talk at a high level about SolidFire itself, it's a true scale-out storage system designed for large-scale infrastructure. And what we mean by that is that we are not bound by a pair of controllers and a bunch of disks behind them. The SolidFire solution is a set of individual nodes that work together in a cluster that can scale from 4 nodes up to 100 nodes, which gives a capacity footprint between 48 terabytes all the way up to 3.4 petabytes with a maximum I/O capability of 7.5 million IOPS. And we don't require any type of specialized hardware to do this. We're using industry standard servers with a 10 gig ED backhaul on iSCSI. So we're able to provide almost 20%, or I'm sorry, 20x the performance of traditional SANs with the most complete enterprise feature set of any AFA out there on the market. That's an all-flash array, for those of you that haven't seen AFA before. And we can do all this for about $3 per gigabyte or less as we scale up. In the context of VDI, we want to talk about 5 different areas where SolidFire allows you to really leverage our strengths. And that's in the area of adaptable infrastructure, eliminating storage sprawl, the ability to get granular scalability for your VDI desktops, simplifying the administration of those desktops, and then lowering the dollar per desktop number that we have as we implement these. So when we talk about that first feature, adaptable infrastructure, one of the key things is being able to go from pilot to production and beyond, right? So if we're going to take a storage infrastructure, we want to be able to grow that from a very small setup to a very large setup, and we're able to do that. And key to that is this idea of design for X and change the Y on the fly. So as a VDI architect, I can't tell you how many times I have had to go out and take tons of input from customers. We've talked to Lakeside, we've talked to Liquidware, we've got these assessments. We think this is what our average IOPS is, our 95% full, IOPS number and all this kind of stuff. We take all of these numbers, we take what our capacity requirements are, and on a traditional array, we would have gone and taken that information and used that to determine what size of array do we need, how many drives should it have, what type of drive should it have, what type of RAID geometry should we be using, RAID 5, RAID 6, RAID 1, RAID 10, right? What type of caching software or, in the case of some of the arrays, what kind of leveraging of EFDs can we use to accommodate that? What's our locality of reference? And there's a lot of complicated things that go into that. And in our case, you always take those numbers, you implement it, and then you find that what you've implemented is different from what you sized for, right? And in our case, that's not a big deal. We can simply change the performance profile of the ones you presented, change their capacities if needed, and we go about our business. So we can adjust the quality of service to give us the performance that we need to adapt to not only the steady state of these desktops as we grow and have different user groups, but also to control, to accommodate these high I/O events that will happen in your desktop. So if you're rebaselining to a new golden image, or you got to reboot all your desktops and install a patch or anything like that, we can set QoS on those volumes back in those VDI desktops and say, okay, during our maintenance window when we're going to do this, we're actually going to increase tenfold the amount of I/O that we want to give to these desktops so that they run through this patching really quick. Right? We want them to go as fast as we can, and we can do that, which is just something that you couldn't do on another platform. And it also allows us to say, okay, if we can adapt to changes in the infrastructure, that allows us to share our infrastructure with other workloads, right? Because now we can say, okay, VDI gets so much, SQL gets so much, Oracle gets so much, and we can guarantee that level of performance inside of the storage system so that when we're running these workloads co-resident, we're always making sure that those application workloads are getting the I/O that they say that they need. The second thing we want to talk about is eliminating storage sprawl. So as we collapse a lot of workloads into the system, we're able to eliminate all the multiple points of management that you would have found in a typical infrastructure, right? Because as a SolidFire cluster grows, it's growing a single entity. It's growing a single management point, right? We're not adding additional management points every time that we grow the infrastructure. When we add nodes, we're simply adding capacity and performance to an existing cluster, right? And that also allows us to collapse applications that have very disparate requirements, right? So we might have a DSS workload that requires large sequential streams and a desktop pool that also has very random write workload heavy requirements. In a traditional infrastructure, you really wouldn't match those two together because that sequential stream is going to pollute the cache of your system, right? You're going to be pushing out all of the data that your desktops are putting in there, right? Depending on the workload, of course. But that allows this ability to give each application, each volume, the type of performance that it needs, allows us to mix those things without worrying about how those applications are going to interact. And then when we get to the idea of granular scalability, we have the ability to incrementally add nodes, which adds IOPS and capacity to our system, right? And we can do this in two areas, right? We can go logically, which means that, like we talked about earlier, hey, our desktop pools are underperforming, right? We've said that, hey, we were going to have 20 IOPS per desktop. We actually found that they actually want 35 or 50. But we can just go in and change the QoS parameters for those ones, and we're done, right? But if the additional capacity and performance that we need outstrips the capabilities of the cluster itself, then we can go in and add nodes to the cluster. And we can do that non-disruptively, right? So there's no forklift upgrade. So when you say, okay, I need to grow my VDI infrastructure, I want to add a node or two, right? It's simply as easy as plugging in a couple of network cables, turning the system on, adding it to the existing cluster, and then driving or adding the hard drives from those new nodes into the cluster. Then the cluster will say, okay, I've got more capacity now. It will rebalance itself. And then once that rebalance is finished, we have a bigger cluster. Maybe we went from 4 nodes to 6 nodes or 4 nodes to 8 nodes, right? Because we had a whole lot of users, or maybe we had some type of acquisition where we're bringing a lot of people in, and we can accommodate those very easily. And simplifying administration. So as a guy who's done a lot with desktops, this is a big deal for me, right? So like we talked before, provisioning used to be a real headache. Now it's simply a question of how much and how fast. We have pools of capacity and pools of performance that we can allocate independently of each other, right? So if I say that I need a 5 terabyte LUN that gets 100 IOPS, or I need a 1 terabyte LUN that can get 15,000 IOPS, I can do that. I'm not bound by the geometry of the disks underneath it that tell me, hey, based on the number of drives you have, here are your performance and your capacity envelopes. That doesn't apply to us. So that really speeds up desktop provisioning and maintenance, right? So if we don't really have to worry about that too much, if I say, hey, I'm adding 50 desktops and I know what their I/O profile is, create the volume, tell it how many IOPS you need, you're done, right? And so we also don't hotspot, right? So as data comes into the system, we spread that data across all the nodes in the system, right? So we don't hotspot individual disks. We don't hotspot individual nodes. We kind of drive that workload across, so we really don't have to worry too much about how we place desktops. The system takes care of that for us. And it also eliminates fire drills from failures, right? So one of the really cool things about SolidFire is the ability to heal from drive failures and node failures very quickly. So in a drive failure in a small node, it takes us about 5 minutes to recover, right? In many cases, in situations I've worked, 5 minutes, the administrator hasn't even gotten the alert yet, right? So in many cases, we've already recovered from that failure before anyone knows about it. In the case of a node failure, we can recover from that in a small configuration in about 35, 45 minutes, right? So, and in both those cases, once the rebuild finishes, we're fully redundant again. We're just a smaller cluster, right? So that allows us to be very, what's the word I'm looking for? It allows us to be very elastic when it comes to failures, right? So we have a whole bunch of different service offerings for support. Almost everyone takes next business day. And the reason they take next business day is because there's no single point of failure in the system, and the systems are very resilient, right? So we don't need parts in 4 hours like a lot of other customers do. We rebuild very quickly, and then we're ready to go again. And we talk about, dollar per desktop. So everyone talks about, how costly VDI is. So SolidFire's got a lot of inline efficiencies that help us drive very dense configurations. So we have always-on inline compression, inline dedupe. We also do within provisioning. So between all those things, we see very good efficiencies of the virtual desktop because, in effect, you're storing hundreds, if not thousands, of copies of very similar data. So our system is able to take all that in and say, yep, got that, update a metadata table, and we don't need to store that in data. And so even at 50 IOPS a desktop and all these things, we're able to deliver storage at $150 a desktop. Now, if you're leveraging something like PBS and you don't need 50 IOPS a desktop, you can get a lot more dense than this, and your storage costs can actually be a lot lower as we talk about these things. But if people are taking fully provisioned desktops and putting them on there and they want to guarantee them at least 50 IOPS a desktop, these are the numbers that are worst case for that. So taking a little bit of a step back, we did a reference architecture with Citrix earlier this year, and I just wanted to cover that really quickly, some of the findings that we had. The infrastructure that you see on the right-hand side is representative of what we implemented. We had 11 hosts running 70 desktops each, and some infrastructure hosts to run all the VMs. We had our login BSI host because we were using login BSI to run our benchmarks. And then we had all that on a 4-node SolidFire cluster. So when we come to the QoS, we've talked about this, how do I size my desktops and the storage that they do? We had 750 desktops, so we created 11 1 terabyte volumes that had 70 desktops each. The last one only had 50, just so you make the math work there. And then for all of the QoS volumes, the way we decided what their performance should be was we set their min IOPS to 25 IOPS per desktop. So if we had 50 IOPS per desktop, 25 VMs, that gets us that 1,750, right? And we did the same thing for max and burst IOPS. And that gave us the, how much and how fast parts of our infrastructure. And then getting into some of the results. So one of the things that, everyone looks at is like, okay, what were you able to do during a boot storm? Well, booting 750 desktops simultaneously, we consumed less than an eighth of the available performance of the system. I think we were pushing about 280 megabytes per second peak bandwidth and over 25,000 IOPS at that point. When we got to the login VSI test, because we wanted to test, user experience for all these things, we ran it up to 750 sessions. The Vcache latency for all the caches for the desktops, was half a millisecond. That's 750 sessions. Again, cluster utilization was around 8%, and we didn't get close to VSI max. So the response time for all the applications on these desktops was very good. And when we talk about efficiency, right? So for those 750 desktops that we had on there, we got a deduplication factor of 6x, meaning that for all of the data stored on the SolidFire appliance by those desktops, we were able to reduce that by a factor of 6. And we also compressed by another 3.25%. You multiply that together, and we reduced the actual storage requirement that you would have had on any other thinly provisioned box by 18x, which is pretty substantial, especially when you're talking about thousands of desktops. There's a lot of detail in that reference architecture. If you want to take a look at it, because there's a lot of things I left out, you can go to solidfire.com/VDI, and that will point you to the reference architecture for XenDesktop, as well as other resources that we have available in context of VDI. So all of that was really under the auspices of doing VDI in an enterprise context, right? So if you're going to do VDI in a cloud context, what are some of the things that you got to look at, right? So if you're considering automating your VDI environment, Citrix got a pretty good cloud story here, right? And what SolidFire gives us in automation and management of the storage infrastructure, Citrix gives us for the automation of the rest of the application stack, right? So when we look at it at a high level, what are the drivers for doing that? Why would we want to do hybrid cloud, right? So we might want to be able to flex the resources in our data center to accommodate changing business requirements in periods measured in hours and minutes instead of days, weeks, or months, right? It's this whole concept of user self-provisioning. Right? I want to be able to order desktops and new applications for development, for seasonal workers, etc. We want to be able to grow that. We want to be able to grow our infrastructure to handle the growth of business and ease the complexity of onboarding new users and customers that we might have gotten through an M&A or just organic growth of the company. And we also want to be able to leverage new resources in an easy manner while transitioning out old assets for hardware refreshes or repurposing of infrastructure for new projects. Right? And so to that end, Citrix has delivered a cloud platform, which is powered by Apache Cloud Stack, which gives us a very fast provisioning model for provisioning infrastructure at scale. It's very flexible in the way that it allows us to allocate infrastructure to these workloads and these deliverables as we need to do it. It's very scalable, right? We can scale to very large numbers of hosts in a cloud platform stack so that we're not managing just a small little environment over here. This is something that we can use to orchestrate our entire environment, right? And it's built on a lot of the APIs that back, Apache Cloud Stack with, AWS-like APIs, right? And so what that gives us is this foundation to build our VDI infrastructure on, right? So we can have Xen app farms that we've deployed on top of cloud platform. We can add Xen mobile apps to it, as well as web applications that we've put out there that we want to provide to our users. And so all of this rides on top of a programmatic infrastructure that we can use to orchestrate the application layer as well as the infrastructure that it runs on, all on top of SolidFire, right? And so SolidFire has got a very rich API that allows us to plug into all of these orchestration engines, right? So the API that SolidFire has basically allows us to do any of the things that you would do in the GUI through the API. So many customers, when they stand up a SolidFire appliance, will go into the GUI, they'll set up the cluster, right? They'll provision their storage, and then that's the last time they ever look at it, right? In the context of VMware, we've got a plugin, the vCenter plugin, that allows us to do all of the management tasks that we do as a VMware administrator from within that interface, right? And for other larger scale implementations like Cloud Platform or any of the other orchestration engines out there, they're writing directly to our API, right? So if you've got a customer that's in there and says, okay, you know, I've got your desktop as a service offering and I want the ability to back up my desktops. Well, you can program a button right in there that says, I want to back up the desktops, and then that will call the bulk storage API inside of SolidFire. It says, okay, for all of these things in this volume, I want you to back them up, right? And then we can back that up to any S3 or Swift capable API out on the back end. We can back it up to another SolidFire appliance. We can replicate, right? Any of these things that you want to do can be done via an API call, right? So that gives us a lot of flexibility with how we want to orchestrate the environment. And so if I really had to break it down, right, I would say that there's 3 takeaways from this deck, right? The first is this true shared storage for applications, including VDI, right? We don't have to dedicate applications to storage arrays anymore, right? We don't have to be worried about how is this application going to interact with all of these different things in my environment, because we can go in and say, okay, for this application, I want it to have, you know, 5,000 IOPS with 5 terabytes of capacity, right? And you'll be guaranteed that that system always gets that performance, right? And so we can also adjust that performance on the fly, right? So if you've got applications that you thought needed 3,000 IOPS, 5,000 IOPS, and a certain amount of capacity, and that changes over time as we grow that database, as we onboard new user groups of the VDI, as we expound into big data territory, all these things, we don't have to re-architect our storage. We can simply go in and say, okay, this database used to need this, now it needs this, and adjust that QoS modifier on the fly, adjust the capacity on the fly as we grow it, and those changes are implemented instantaneously, right? And then all we have to do is go into the application or the OS, tell it to utilize that new capacity. If we expand the capacity, the performance is available immediately. And in the case of, you know, scalability, right? SolidFire plus XenDesktop plus Cloud Platform equals the scalable multi-tenant multi-workload architecture, right? So we can put all these applications together. They work well. We can architect around it. We can automate it. And so a lot of this helps us deliver this scalable reference architecture for VDI based on SolidFire. So all that being said, if you want to know more about this, you can go to solidfire.com/VDI. If you're big into Twitter, you can hit me at JediMT. SolidFire is also an available Twitter handle that you can use to answer questions. All of our tech solution guys are on that. You can be hit at this phone number for all of the sales questions if you have that. If you have any other generic questions that you'd like answered, we can reach those at info@solidfire.com. With that, I'd like to turn it back over to the Citrix guys. Thank you very much. I really appreciated the opportunity to speak with you guys.
Okay, great job, Aaron, and appreciate the good overview today. There were a couple of questions on, you know, getting the slides and the presentation materials that that were provided today. So we'll make sure that those are sent out to the attendees. Aaron, I have a question for you. One, what is burst IOPS and how is it different than max IOPS?
So the SolidFire platform, as part of its QoS implementation, has this concept of minimum IOPS, maximum IOPS, and burst IOPS, right? So minimum is just what it is, right? You know, I always will get this number of IOPS at a bare minimum. The maximum IOPS is kind of the upper window there, right? So I will always guarantee your minimum IOPS and will allow you to run up to your maximum IOPS, right? If you have a workload that runs underneath the maximum IOPS for any period of time, it's building up credits, right? So we use a credit-based system for QoS. So if you're a desktop and you're cruising along, you're doing your thing, you're running at your min IOPS level, you're accruing credits, right? And then at some point, let's say you install iTunes or something like that, right? What we do is say, okay, you are now requesting 200 IOPS to do this install, right? And so we will allow you to burst up to 200 IOPS or whatever that number is for a period of about 60 seconds as we allow you to run outside of your maximum. And over time, we'll kind of schedule you back down to your maximum IOPS again. So what that allows us to do is basically give away IOPS to desktops or volumes that have high I/O requests for short periods of time, like doing a little install or something like that. So it allows us to basically give more performance on demand for those desktops that need it. So right now, these QoS values are based on a per volume metric, right? In early 2015, VMware will announce vVols, which are virtual volumes, which basically makes every VMDK a virtual disk, right? And at that point, we'll actually be able to give per QoS recommendations and enforcements on a per disk level. So if you've got a VM, you know, with a disk that's your personal desktop, we'll be able to tell that desktop, hey, you get 50 IOPS each, and you can burst up to 200, right? Whereas right now, these values that we provide are on a per volume metric. So if you've got, you know, a couple of desktops on a volume, whatever you give as the min, max, and burst IOPS is shared among all those desktops.
Okay, excellent. Thank you, Aaron. Then we do have another question from the audience related to performance. When quoting the top line IOPS numbers, what is the read-write ratio and I/O size that is used? So for any of the systems, we've got three models. There's a 3010, a 6010, and a 9010. And the 3010 and 6010 are rated at 50,000 IOPS. The 9010 is rated at 75,000 IOPS. The read-write ratios that we give to hit those numbers are 80-20 read to write at a 4K I/O size. Okay, pretty straightforward. And if others have questions, they can provide those questions in the GoToWebinar question panel. Another question we received, Aaron, relates to management. Do you have an API?
Yeah, we talked a little bit about this in the deck, but we've got a REST-based API that we can use that allows you to do any of the management functions that you would do within the GUI of the appliance from an API, right? So if you want to go create a volume, change the QoS, add user accounts, expand storage, any of these things, they can all be done through the API, which is key when you're talking about these cloud-based infrastructures, right, where we want to automate everything, especially for service providers, right? You know, they want to be able to write down into the storage system and say, okay, give me this or do that, respond to that, right? So the API allows us to do all of that stuff right there. We don't have to rely on SNMP traps or anything else like that. You know, you can write directly to us and tell us what you need done, and we will respond.
Okay, thank you, Aaron. Another question from the audience relates to the platform. Can you tell us more about the actual SolidFire nodes and in what kind of server, you know, type of SSDs, et cetera, are involved? Right. So the system uses, currently anyways, Dell R620 servers with, you know, varying amounts of CPU and RAM depending on what model you're using. As far as drive loadout goes, each one of these servers has got 10 SSDs in it, and we use those for primary storage and metadata. For the different models of servers, so
the 3010 versus 6010 versus the 9010, we're changing the capacity of the drives as well. So the 3010 has got 300 gig drives, the 6010 has got 600 gig drives, the 9010 has got 900 gig drives plus more memory and more CPU, which is why it also has more IOPS capacity as well.
Excellent. Thank you, Aaron. Those are the questions we've received thus far. Those are great questions, everyone. Thank you for providing those questions. We do have a little bit of time left, and I did want to allow other questions to come if there are audience members that would like to provide those. Are there any questions from the panelists, other panelists that they'd like to ask Aaron related to
Keith,
his presentation?
Keith, I was just going to add a couple things to what Aaron was saying. By the way, great job, Aaron, and thanks everyone for attending. When you look at the SolidFire architecture, it may or may not have been stated when you talked about the nodes. The minimum number of nodes to start a SolidFire platform is 4. Now, over time, you can mix and match those nodes. You can separate and deploy elsewhere. So you're not bound just by one model in the nodes. Over time, there's lots of flexibility about that. They're also back-end connected by 10 gig Ethernet and also have a PCIe flash card for lots of the non-volatile RAM cache and ways to ensure you have consistencies of reads and writes. So if there's any other questions about the hardware platform, those are a lot of easy questions for us to answer. I think a lot of what was shared today is the goodness of the XenDesktop platform and how to take it at scale, and then also how to put it into a desktop as a service automation with not only desktop workloads, but also mixing with enterprise workloads.
Thank you, Keith. Again, if there are questions, you can provide those in the GoToWebinar panel, or if there's questions post-webinar, you can send those to citrixready@citrix.com or in the directly to SolidFire. Okay. I don't see any other questions, so I wanted to let me thank our Citrix Ready partner, SolidFire, and Aaron Patton for presenting the webinar today. Let me thank the attendees for your time, and we appreciate you taking time out of your day to join us and for the great questions. We, again, will make the presentation and recording available to all those who attended, and we'll go ahead and conclude the webinar. So thank you very much. This concludes our webinar, and hope everyone has a great day. Thank you.